my peeps, we're moving on. Some books call this combined inequalities. I've seen some books call them compound inequalities, meaning you're putting two statements together with the word. Today our word is or. Or in math is just like an or in English. If your parents say, hey, look, we want you to walk your dog or walk your little brother. And you say, okay, I went and walked my dog. And you left your little brother alone. It's a true statement because you accomplished one of the two. Now, if you walked your little dog and your little brother, that's still a true statement because you accomplished both. The only way it's false is if you gave your brother cake and left your dog in your room. Then nothing was done. So, or as long as one condition is met, it's a true statement. So if I have this, the same direction, they're both greater than, here's greater than 3, here's greater than 6. Now make sure you align the numbers right. 3's to the left of 6. Now or is wherever there's shading. So I have to bring down this. And then this one's already part of it. So the answers would be anything greater than 3. So whenever it's going in the same direction, it's the longer one for or. Now this one, opposite directions. One's less than, one's greater. So here's less than 6. Here's greater than 10. Now, you do not have to draw all three graphs. One more time. Do not have to draw all three graphs. Most, or many, I should say, can see it. Now, or just bring it down. Less than 6. Greater than 10. Both those are true. So you say, Mr. Muffrey, what about number 11? 11's not smaller than 6, but it is bigger than 10. So it causes one of the statements to be true. Now this one, again, opposite direction. One's greater, one's smaller. Here's greater than 4. Woohoo! Here's less than 7. Woohoo! Now wherever there's shading for or, bring it down. Here's greater than 4. Woohoo! Here's less than 7. Woohoo! So everything's covered. This is closed dot because 4 is smaller than 7. Closed dot because 7 is bigger than 4. Only one of the conditions have to be met, or is the only one that can have all reals. And cannot, we'll look at and in the next video. So this one, always simplify first or solve first. If you want to say it that way, might be better. So divide by -1, so x is less than -7. And I want the one smaller than -7, but also or bigger than 10. I kind of said that wrong. Less than -7 or bigger than 10. Well, here's less than -7. Here's bigger than 10. Whee! Here, subtract 1 from both sides. So 2x is greater than or equal to 6. Divide by dose. X is greater than or equal to 3. This one, yep, I thought I pushed it off the page. So negative x is greater than or equal to -7. Divide by -1, but Mr. Muffet, whenever you multiply or divide by negative, you gotta switch the direction of the inequality. So this is what you have. Less than 7 or greater than 3. Well, notice everything is being hit. All the numbers greater than 3, less than 7, So it'd be all reals. And we'll talk about this in class Tuesday and Thursday. But there's 3 problems. See if you can figure them out for me, please. And then turn me back on. Okay, here we go. So subtract 1. 1/2 x is less than or equal to -12. Multiply both sides by dose. Now notice I did not switch the direction of the inequality because I did not multiply or divide by negative. Here, multiply both sides by 2. So I want the numbers larger than 20 or smaller than negative 24. So they're going in opposite directions. Whee! Solid dot or bracket. 20, I think I said. I hope I didn't make any boo-boos. Woohoo! Okay, a little bit more challenging here. Subtract x, 2x plus 4 is greater than negative 10. Okay, subtract 4. So 2x is greater than negative 14. Divide by dose. X is greater than negative 7. Whoa! This one. Oh no, fractions, but we just have one. So multiply both sides by 3 halves. So x is less than 2 goes into 10. 2 goes into 20. 10 times 3 is 30. So I have, sorry about that. I left the door open to bring in packages. I got a bug in here. So negative 7. So it goes this way. 30s to the right, it goes this. Oh, everything is covered up. Notice I got color in that open dot because negative 7 is less than 30. So it's all reals. All reals, my friends, all reals. Okay, this one. Oh, Murphy getting tired. I need a donut. Oh, yes, I do. So x is greater than 4. Here, subtract 6. Negative x is greater than 14. Oh, but I got to take the opposite of both sides. So x is less than. Switch the inequality because I divided by negative. Well, shoot. So I need the number smaller than negative 14 or bigger than 4 at the same time. So here's greater than 4. I'm going to do, oh, there's no equals, so parentheses. And I need less than negative 14. No solid, so parentheses. Woohoo! Now, if you want to use crayons, I don't care. Some people like to color. How'd you do on that? Okay? Okay. Well, I hope that was okay. Not too bad. So, have a good day.